Welcome to Storage for System Strength, a viewpoint study from Elia Group. I'm Isabelle Castellijn, Head of Communication and your host for today. Across Europe, battery storage is surging. It's transforming the way we store and use electricity. Declining costs, supportive legislation, and increasingly attractive market conditions are all fueling the rapid rise in battery projects and grid connection requests. But this rapid growth also brings new challenges. In this viewpoint, we will explore what it will take to turn the surge in storage into a real system strength. Together with experts from industry, policymakers, and the energy sector, we will take a closer look at how we can ensure that every battery added doesn't strain the grid, but makes it stronger. To begin, let's hear from Bernard Gustin, CEO of Elia Group.
This new viewpoint, Storage for System Strength, in anticipation of the upcoming EU European Grids package, is building on our previous work across the European energy landscape on flexibility and system integration. It is turning to one of the most pressing challenges facing Europe's electricity systems: the uncontrolled surge of battery projects and the widespread grid congestion. But let's be very clear, this study is not the final word. It's a conversation starter, a strong invitation to act together. We must urgently reflect on how technological innovation, alongside policy reforms, can ensure storage truly provides value where society needs it most. Storage is a cornerstone of the future, helping to integrate renewables, support consumers and industries. But today, the first-come, first-served connection process risks blocking capacity that should go to projects which drive real progress, those that support economic growth, competitiveness, and the transition itself. At Elia Group, our mission is clear: to safeguard the integrity of the grid, ensure security of supply, and enable economic development, always in the public interest. Thanks to our strong position with two national TSOs, we can combine experiences, share lessons, and mutualize know-how to serve this purpose. But we cannot do this alone. These answers to these challenges will be co-created by TSOs, regulators, policymakers, developers, and innovators working together. By connecting wisely, operating efficiently, and planning collectively, we can turn today's storage surge into real system strength and build an energy future that is sustainable, affordable, and secure for all Europeans.
As Bernard has clearly emphasized, the pace of change is remarkable, and it raises urgent questions about how we connect and operate new storage projects. So what's driving this surge across Europe? Let's take a closer look.
Battery costs are falling fast. Legislation is opening doors. Market conditions have never been more attractive. At Elia Group, the surge in grid connection requests is already visible.
Elia Group landed on the topic of storage because it was an urgent topic at that moment. So we are seeing the requests coming in of a lot of battery developers who want to connect to our grid. And we thought it has to be the time that we are thinking ahead of what will really happen with all of those storages coming into the system. What do we need to change?
This viewpoint focuses on how to move forward, together with all stakeholders.
In the past, we were always saying we need something. Like my first viewpoint of the team was on flexibility. There we said we need more flexibility in the system. We really need it now. We need more industry decarbonization. And this year we are really seeing something. So it's a good progress. So we are seeing that storage is really in the system. It wants to connect. It comes in the system. And we really need those storage also to connect. But now we need to create the right framework so that they really can help the system in the end.
And this surge isn't just happening in Belgium or Germany, it's global. As Colin McCarrick has stated, the fastest growing parts of the energy transition, solar PV, batteries and electric vehicles, all require robust and streamlined processes for grid connection to ensure they're able to continue their upward trajectory. These sectors together accounted for $1.3 trillion of the $2.1 trillion invested in the energy transition globally in 2024. And this share is set to rise even further this year. But rapid growth also brings new challenges, especially at the grid connection level.
The scale is big, it's actually very big. In Belgium and Germany alone, it represents 250 gigawatts of capacity that is currently reserved for batteries. So it's massive. Actually, not all of these projects will materialize, but the landscape today is actually a landscape full of projects that are for some immature or speculative, and these projects are clogging up all the other clients in the queue.
And from ESE, the European Association representing the storage sector, the message is the same. Europe's grid is under strain.
Phantom projects, which very often come because the demand is done very early in the process, given the delays, are clogging up the connection requests. This means that projects which have a higher societal value and which are needed from a system perspective because of the need for flexibility in your system in order to connect more variable renewables are therefore hampered.
Renewable energy developers and energy suppliers like Eneco that want to connect new renewable projects are also impacted by long queues.
Regarding the massive connection requests, there is a queue for wind, electrification and BESS connections. And it's a very important issue because if we do not act on this, we will move further away from realizing our climate goals.
So, how do we make sure that society benefits most?
The solution in our position is to say that the connection requests should be vetted following the societal added value. The better it is for society, the more it brings flexibility, the more it should be moved up in the queue and therefore connected faster to the system.
A strong framework is needed now to guide TSOs in how to strengthen the grid.
We do not only think it's a technical problem, but mainly a governance problem. And it needs to be tackled, but not at the discretion by the TSO. We believe that there needs to come a regulatory and a political framework with set criteria by the CREG and the government.
It's clear, if we want to develop a sustainable, affordable and secure grid infrastructure for the future, we will need a multiple solution approach. What will it take to make storage work for the system?
For years, grid connections have been assigned on a simple principle: first come, first served.
How does it work? It's actually quite easy. As its name is saying, the first client that is coming to us received the connection the first. It was meant to ensure a level playing field between the different grid users initially. And it worked quite fine up until now.
As in other countries, we see in Germany that first come, first served is already under significant pressure. From Fluence, a global leader in battery storage, Policy Director Lars Stefan sees that pressure rising fast. Connection requests are streaming in, and developers are encountering a longer and longer queue.
It's often reported that we have more than 500 gigawatt of grid connection requests in Germany. Actually, 50Hertz just last week unlocked around 30 gigawatt of interconnection requests for energy storage, but also other assets. So there has been this huge wave of energy storage project requests coming to the grid operators, and in all fairness, they're a bit overwhelmed with this, which is creating problems for developers. Then if we look into how to get projects into the ground, then really getting the permit with local permitting authorities and getting the grid connection with the connecting grid operator, these are really two of the key bottlenecks that developers see. A big problem at the moment in Germany is that you have this first come, first serve principle. In other countries, we already see that quality of project development takes a key role. For example, do you have permit? How ready are you with your permit? How ready is your technical concept?
And at the EU level, Member of Parliament Anna Sturck sees the same issue. Today, first come, first served is preventing us from having a grid that functions for society.
We are seeing massive connection queues ramping up all over Europe. And we don't only need more capacity in our grids, we need to use the capacity we have to the best extent and most efficiently. Now, it can't be that we have connection agreements being hogged and not used or even auctioned off or sold off to other players. No, we need fair and transparent priority connection criteria to make sure that those projects that will actually help us to have a more efficient grid and to have a true path towards the green energy transition happening. That is what we need in order to have a true, efficient European grid.
Giles Dixon, another leading voice in Europe's energy transition, believes that storage is no longer optional. It's a strategic necessity. Storage is essential for the transition to cheaper and cleaner energy. It needs to be permitted and connected to the grid as soon as possible. And priority should be given to those storage investments that are of the most strategic value. Don't do first come, first served. Identify the projects that matter most and get them permitted and grid connected now.
It's time to move beyond the first come, first served basis. The new approach should be forward-looking and support consistent and strategic grid development. This means to have a level playing field between all grid user categories, such as renewables, industries, commercial players, and of course also storage. The key pillars in the new approach are active queue management and allocation of available grid capacity in line with policy objectives.
To unlock the full value of storage, grid connections must shift to being strategic. This means not just prioritizing the projects that showed up first.
The energy transition is evolving. It's not just about adding assets anymore, it's about making them work smarter. How can we assure storage can play that role?
Our study shows that grid-unaware storage can increase redispatch needs by up to 14%. To avoid this, the system needs grid-beneficial behavior, combining market signals with grid signals, so storage strengthens the system instead of straining it.
In order to ensure that the battery is not exacerbating existing grid congestion or also creating additional one, we introduce grid signals. Grid signals have to vary over time and location, just as congestion does. The instruments we specifically looked into were flexible connection agreements, also known as FCAs, that limits the capacity of the battery injecting into or withdrawing from the grids. And also we looked at dynamic grid tariffs, which provide an additional signal to the battery that it can combine together with the market signal to make their optimization.
Grid signals are essential to prevent congestion. Storage companies agree, but warn that regulation must evolve too. Germany is reforming its grid fee system. Storage is currently exempt from grid fees.
There are no signals from the grid operator to understand what is the status of the grid. What is my operation doing to the grid right now? So we need to provide signals to loads and generators and energy storage about the situation in the grid to better understand how to optimize and operate assets connected to the grid. It's really important to get energy storage operators those signals, because at the moment they only have signals from the energy markets. I think there's a growing realization in the storage industry, but also in the energy industry as a whole, that dynamic real-time signals based on the real-time situation of the grid should be the way forward.
Storage can react in milliseconds, but that speed can also create challenges. Grid operators need ways to leverage the full potential of storage.
What the control center needs to include batteries successfully is that batteries react on signals. Those signals can either be signals that we are sending out if there's already a congestion, too much power flows going to our system, which the system cannot cope with, or is it voltage limitations that might be endangered? The other case is that we see in the planning that batteries might endanger those limits and that we need to send limitations to the batteries in advance so that they are free to do whatever they would like to do below those limits, but that the control center can set limits that are not exceeded by the batteries.
From our analysis, we see that energy storage system operators operate their system based off of market signals today. In the future, this needs to evolve towards an operation where they take into account the state of the grid. And so this means that these market signals that are already available today need to be complemented with signals that accurately reflect the state of the grid, golden grid signals. In this way, these operators can bring the value of the assets that they control, the value of the flexibility they hold in their hands, to the place where it is most needed. And so this involves bringing it to the place where it's most benefit to the system, markets and grids combined.
Grid-aware storage isn't just a technical upgrade, it's a new operating model. And for that, we need the right signals and the right regulation.
Let's look at how we turn storage from a passive market player into an active systems service provider.
First of all, the system is changing fast. More renewables mean more unpredictability. And without flexibility, the costs will keep rising. From Energieville, Belgium's leading research centre on energy systems and flexibility, General Manager Bram de Wispelaar explains it clearly.
Het is algemeen, flexibiliteit brengt de systeemkost naar beneden. Met batterijen word je nog flexibeler natuurlijk en kan je die systeemkost effectief naar beneden krijgen.
Today, most batteries simply react to market prices, buying low, selling high. Valuable? Yes. But to support the grid, they must move beyond trading and become true active system assets.
No flexibility, no party. Batterij is inderdaad een passief component, maar als je er een battery management systeem op zet, dan ga je ook de batterij sturen. En die kan je sturen op verschillende niveaus. Ten eerste heel lokaal. Wat heb je lokaal van overschotten of van piekverbruik? Maar dan ook naar de markt toe. Gaat het over hoge prijzen of negatieve prijzen? Hoe kan je daarop inspelen met de batterij om ook de goedkope energie binnen te trekken? Of op momenten dat de batterij kan afgeven, ook effectief inspelen op de hoge prijzen en er geld aan verdienen. En dan een derde niveau is natuurlijk die flexibiliteit leveren aan het systeem voor het evenwichtsbeheer.
With the mix of renewables increasing, replacing fossil generation, the system needs new services to ensure stability.
In Europe, we are striving towards a decarbonized energy system by the year 2050. As part of the energy transition, there will be increasing shares of renewable electricity generation, especially by wind and photovoltaic. Now, this has two implications. First of all, renewable power generation, just like from wind and solar, will always fluctuate, just by nature. Also, the power is fed into the grid from many distributed grid connection points. This makes system operation more complex. Second, there will be fewer conventional thermal power plants in the power system as the energy transition is progressing. This is important to consider because traditionally, thermal power plants have been the providers of ancillary services. So what we do need now is new providers of ancillary services. On the one hand, renewable power producers will play an important role, but this is also where storage gets really important in contributing to system stability.
Today's batteries mainly cover minutes to hours, But the next phase of the transition will require flexibility across days and eventually across seasons. And from the Clausthal University of Technology, Professor Ines Hauer explains the next challenge.
Long-term technology should be capable to discharge its energy longer than 24 hours, up to 100 hours, so that we are able to bring energy in the system for a so-called the Dunkelflaute. From my point of view, another definition is also quite important. We have to store energy longer than several months. In the future, we will have really high PV peaks in the summer, and we will see a really high surplus of energy, which we have to shift in the winter times. And for this issue, this long-term storage technologies should be able to store energy over different months, over 6, over 10 months, with minimal losses.
Storage can deliver system services, but only if the technology and regulation evolve together. TSOs need clear rules, operators need certainty, and the framework needs to look to the future, not the past.
What's clear is that storage can play a central role if we work together to unlock its full potential. We have looked at 3 possible solutions as a way forward in addressing the storage surge. This study is an invitation for further conversation with market players, regulators, and other TSOs. Let's turn to our CEOs to hear their vision.
Hardly any other topic is being discussed as intensely in the energy sector today as battery storage. With the energy transition, the need for flexibility in the power system is growing fast. Large-scale storage has the potential to become a central pillar of that system. Batteries help integrate renewable generation, smooth fluctuations throughout the day, and relieve both the market and the grid. But for storage to reach its full potential, the right framework must be set now. Falling cell prices, growing price volatility, and temporary incentives, such as grid fee exemptions in Germany, have triggered a real surge. In the 50 Hz area alone, we now see connection requests exceeding 100 gigawatt, almost 7 times the power currently flowing from our grid. Across Germany, it's more than 200 gigawatts. This dynamic is exciting, but it also exposes the limits of today's processes. The current first-come, first-served approach was never designed for such a flood of speculative applications. It rewards speed, not quality. Some projects reserve capacity they may never build, leaving others waiting and delaying real investment in industry, data centers, and renewables. We need a new system-oriented way of working. And this new system isn't about making a TSO's job easier. It's about acting responsibly with a critical public asset. Every unnecessary grid expansion, every idle reservation is money that could be better spent on renewables, on flexibility, on innovation, on affordability. At Elia Group, we are proud of how far we've come. Together with our partners, we've connected record levels of renewable generation, strengthened interconnections across borders, and made our grids smarter and more digital. In the coming weeks and months, we will continue to build understanding, align perspectives, and co-create the answers we need. Because no single actor, not a TSO, not a regulator, not a developer, can do this alone. You can count on Elia Group to keep safeguarding the integrity of the grid, ensure security of supply, and always in the public interest. We are entering a new era for energy storage, one where batteries don't just follow the market. They serve the system. How, where and when storage operates significantly impacts the future of the grid.
We are entering a new era for energy storage. One where batteries don't just follow the market, they serve the system. How, where and when storage operates will shape the future of the grid. As storage scales up, its behavior matters more than ever. It affects efficiency, it affects stability, so we need to address not just connection, but how storage operates once connected. When TSOs, market operators and innovators work together, batteries change. They move from passive assets to active partners. This isn't about replacing one technology with another, it's about building a smarter, stronger foundation for the energy transition. That's why Elia Group is taking the next step. In Belgium, we are working with market players to define a new study. It will explore market design options for an optimal integration of battery storage. Integration that is truly grid positive. And this won't happen behind closed doors. In the coming weeks, we will co-create the scope with partners. Throughout 2026, market participants and regulators will help shape its execution. Our goal is clear: to understand how storage can contribute most effectively to a stable, affordable and sustainable energy system. Not just for Belgium and Germany, but for all Europe. At Elia Group, we know the statu quo is not an option. We've come a long way, but we can and must go further. Together, we can make sure the surge in storage is remembered not as a crisis of congestion, but as the moment Europe proved its strength lies not in competition, but in coordination.
The surge in storage is reshaping Europe's electricity system. Whether it becomes a strain on the system or a source of strength depends on how we act together. We thank you for taking time to join us today and invite you to visit the Elia Group website for the full report.
The Viewpoint study would not have been possible without the support of the following partners.